So getting started with RSpec. That's weird. This is a famous person. And I think I gave this quote earlier in the course. This famous person said, debugging is twice as hard as writing code. So if you write the code as cleverly as possible, you don't have enough cleverness left over to debug it, basically. Anybody remember who I said this famous person was? Little computer history trivia. This is the designer of the C language. That's Dennis Ritchie. And by the way, a Turing Award winner. Here's another Turing Award winner talking about debugging and testing, who says, testing can never demonstrate the blank of errors in software, only their blank. Anybody care to try to fill in the blanks? Can never, yes, sir. In that order, testing can never demonstrate the absence of errors in software, only their presence or only their existence. That is exactly right. So it's kind of a downer view on testing, to be honest. But I think it's a way of saying that even if you have what you think is 100% test coverage, that's no guarantee that your software will always behave correctly. Nonetheless, high coverage is a good thing to shoot for. And by the way, that was Edgar Dijkstra, many consider the sort of father of the idea of object-oriented programming. If any of you have spent time at any of the Google facilities in the Bay Area, on most of the toilet doors, the stall doors, they have a poster that has this little picture on it, debugging sucks, testing rocks. Google has one of the best cultures of testing, really of any software company that I'm deeply familiar with. And I think I mentioned that they even have, or used to have, I haven't been there in a while, a program called Testing on the Toilet, where inside, like over each urinal and inside each stall door, they have a thing that you can read in about a minute that is some idea or practice that you can take back and make your testing better. So they believe in testing, we believe in testing too, and hopefully by the time you're done with 169, you will as well. So let's now talk about testing at the level of actually writing code. So let's talk about the basics of the anatomy of a test. You sort of have already seen it because Cucumber actually makes this explicit. Every test really has three main components, and I learned that there is now another acronym for it called AAA, which is arrange, act, and assert. Arrange is set up whatever preconditions or assumption the test relies on. So that's like the given part of a Cucumber scenario. Act is do something that stimulates the software. That's usually the when part of the scenarios. And assert is check that something did or did not occur as a result. And that's usually the then steps from Cucumber. So Cucumber happens to make those explicit in its domain language, even though, as we know, given, when, and then are actually just aliases for the same method. But they are sort of the three different parts of a test. And every non-trivial test more or less looks like this. Now, in the very simplest case, if let's say you're doing a unit test for a function that has no side effects, it doesn't have any preconditions, all you're really doing is checking that given the right arguments, it returns the right value. In that case, there isn't really anything to do in the arranging of preconditions. The act is just calling the function, and the assert is making sure that it returned what you thought. But as you'll see, most interesting things you want to test are not that simple, and you need to do something a little bit more sophisticated. So let's take a look at an example, or technically three examples. If we have a hypothetical class and method that does Fibonacci numbers, which you've seen a zillion times in the lower division, I imagine. The very first test here, and by the way, this is an introduction to the domain-specific language that RSpec uses. It's just Ruby code, but it has a function called it, in the same way that Cucumber allows functions called given, when, and then. RSpec has a function called it, which takes a description of a test case and a block of code that actually does that test. So the very simplest one on top, and each one of those blocks is sometimes called a spec because it specifies one behavior, just says it computes the right Fibonacci number. So that's a really easy one. It looks like it's trying to pull out the fifth number of the Fibonacci sequence. If you mentally do the math, that should be 8. And it just says expect the result to equal 8. That's the assertion. So where's the arrange? There isn't really any precondition. What's the act? The act is actually calling this piece of code, which we want to test. What is the assert? It's this. Expect x to equal 8. And what kinds of things can come after 2? There's a point. So RSpec has a whole section of expectations, which are things that you can assert about an expression. I'm going to use some simple ones here, but in the context of doing the subsequent homework, the one that comes after the one that's due next week. And you can also look at the RSpec documentation, but there's a zillion built-in matchers. And there are things like, a lot of them are quite powerful. You can say that, if the thing that's returned is a collection, it should include a certain element. If the thing that's returned is a string, it should match a certain regular expression. There's a bunch of other stuff. Here's another simple case. It rounds up if you give it a non-integer argument. Same basically idea. What about this one? It expects something to b underscore 0. B underscore something is a shorthand, which means call the function 0 question mark on whatever the subject of the expectation is. So this is basically, Ruby will turn this into taking whatever is in the expect clause and calling 0 question mark on it, which returns true if the thing has a 0 value, whether it's real or complex or an integer or whatever. And all these things get wrapped up in a block that groups related test cases. So describe doesn't actually do anything, but it groups a bunch of cases together. And as we'll see, it also gives us the ability to set up common preconditions for a group of related cases. So what am I showing here? Kind of, what's the high order bit? It's an example of the simplest kind of test, which is to assert that something is true using expect. Expect expression to meet some criterion. The criteria are listed in this built-in matchers document, but some examples are you can expect x to equal something. You could also say something like expect x not to, like not underscore 2 to equal something, or expect x not to match or not to be 0. There's a pretty strong emphasis on making the test pretty readable. And each one of these blocks tends to be quite short because the goal is to test only one behavior. Right? So the reason you want to do that is that if a test fails, it's going to fail for an extremely narrowly defined reason, and then you can go off and debug it. Here's an example where I'm testing a few different aspects of this Ruby class called book in stock. And focusing on the part down here, the describe getters and setters, basically what I'm trying to do here is I want simple tests that check whether the getters like ISBN and price will actually return those values. I'm also checking that I can set those values through setters. So this is the kind of stuff that you saw with attr_accessor, but I'm showing what it would look like to write a simple test that actually tried to do some of these things. The big difference between this example and the previous RSpec example is that this one requires some setup. It requires some arrange steps. In particular, for each one of the examples, because I'm going to try to call some instance method on an instance of book in stock, I need to have an instance of that object available to call the method on. Now, I could take this line, book equals bookinstock.new. I could insert a copy of that into every one of these examples, because in this case, the setup for all the examples is basically the same. I just need to create a valid copy of an instance of the class so that then I can actually try to call methods on that instance. But because the setup is the same in all the cases, what I've done is I've pulled it out into this block that says before each. So what will happen when this set of test cases is run is that before each one of these is done, the before block will run and set up this instance variable at book, which is then available to that test case. And this will happen every single time. So this is basically like the background steps in a Cucumber scenario where they apply to every scenario in a single file. The before each applies to everything within a single describe block. So this is the reason that describe blocks are useful for grouping together a set of related tests. If those tests share some code for things like setup, you can put all the setup code for all of the examples in that group into one place. So every test still has the same 3 parts, right? The arrange part, which we've pulled out as a before block that happens before each test. And here's an example of the act part is I'm trying to use the setter for ISBN to set this ISBN field to a new value. Right? Now, these tests are testing something pretty trivial, so I would expect this to work. But this is the actual line of the test where I'm trying to act to stimulate the code to see if it behaves the way I expect. And what's the thing that I expect? That will be the assert part, where I'm now checking that when I call the accessor method for ISBN, I get back the thing that I just saved and not something else. Okay? So the sort of key point of this example is when you have preconditions or arranged conditions that are the same for a whole group of tests, you can put all those tests together into a describe block and then put a before block that actually sets up the preconditions the same way. And by the way, and this will run every single time, right? So there's 4 test cases here, and for the very first one, it will first run the before block and then the test case. Now the second one, it'll run the before block and the test case, and every time a new test case is run, everything that has happened before is forgotten. So you can think of every test case as starting absolutely from a clean slate. The only way that there's any preconditions that are prearranged is either what's in the test case itself or if there's something in a before block. But the effects of doing a before do not last longer than a single example, right? So everything about both frameworks that we're using, RSpec and Cucumber, is designed to help your test be independent by default. So nothing that any test case does is going to sort of persist or bleed over into future test cases. Okay, so questions about this example. As always with this, I'm trying to give you the lay of the land overview. So I'm not going to go into a lot of detail on every possible thing you could have done. But I want to make sure that you understand the general template of arrange, act, assert, and that you start getting familiar with the way that you write those kinds of things in RSpec, what expectations look like, and so on.